farmers and enthusiasts, and welcome back to African Farm Tech.
Hello everyone, I'm Mustafa Jarson from African Farm Tech. I come back within the chapter 1. In the last of our video, we discussed the course outline of engineering material course that we will be discussing in this semester. Today we will start the chapter 1, material property and product attributes. Students, at the end of this course, I will expect from you to identify and articulate the main concept of engineering material, including their classification, properties, and applications. Explain the compositions and the internal structures of an atom, highlighting the key components such as protons, neutrons, and electrons. Articulate the influence of compositions in the internal structure of an atom on the material properties of the substance. You will provide brief descriptions of ionic, covalent, metallic and hydrogen, and van der Waals bonds. You also physically create models of diagrams representing the structure of different types of the bond, and also express an appreciation for importance of understanding atomic structure in material science. Now let us start. Student, what is material for you? And what types of material you know? Discuss for 1 minute and tell to your friend.
Hello, farmers and enthusiasts, and welcome back to African Farm Tech. Ever pondered over
Yes. The definition of materials is different according to different scholars and different fields or different principles. According to Webster dictionary, the materials are defined as substance of which something is composed or made of. That means everything is composed from the materials, including the human being. Since the earliest days of the evolution of mankind, the main distinguishing features between human beings and other mammals has been the ability to use and develop material to satisfy human requirements.
From the dawn of time, humans have stood out from other mammals by our incredible knack for crafting and using materials to meet our needs. It's in our DNA to innovate, adapt, and create tools that shape our world. Whether it's fashioning tools for hunting, building shelters, or inventing technology, our ability to manipulate materials sets us apart. So next time you pick up a tool or admire a structure, remember it's this unique trait that defines our humanity.
That means, if you give for the another animals or mammals the gold, they can't able to change the gold into another resource or monies. So the human beings detail and easily and convert one material from another materials and use it. So we can say that the material is the thing that distinguish human beings from other mammals. Nowadays, we use many types of materials fashioned in many different ways to satisfy our requirement for housing, such as heat, furniture, clothes, transportation, entertainment, medical care, defense, and all other trappings of the modern civilized societies. The most material doesn't exist in pure shape. It always exists as you remember from the lower grades.
Ever wondered why we don't find materials in their pure form? Well, here's the scoop. Most elements exist as ores in nature. That's right, whether it's gold, iron, or copper, they're usually mixed with other compounds. So when we mine these ores, we have to extract and refine them to get the pure stuff we use in everyday life. It's like finding treasure in a sea of rocks. Next time you see a shiny metal, remember it took some serious work to get it looking that good.
Okay, there is another activity or question. So, if we define materials as such, if the definition of material is as such, why do you learn engineering materials as important?
Hello, farmers and enthusiasts, and welcome back to African Farm Tech. Ever pondered over
Time's up. The knowledge of materials and the property of the great significance for designing. The machine element should be made of such material which has property suitable for the condition of operation. In addition to this, a design engineer must be familiar with the effects which the manufacturing process and the heat treatment have on the property of the materials.
Understanding materials and their properties is crucial for a design engineer like me. I carefully select materials that match the operating conditions to ensure the durability and efficiency of machine elements. It's not just about choosing the right material, but also knowing how manufacturing processes and heat treatment can impact its properties. By mastering these aspects, I can create designs that are not only functional, but also optimized for performance. So, next time you see a well-designed machine, remember it's all about the materials and how they're treated.
Now, let's pass to the next topic about the classification of material. Material can be classified based on the phase as solid, liquid, and gases. Based on the physical and chemical properties, they classified as metal, metalloids, and non-metals.
Ever wondered how materials are classified based on their properties? Well, it's all about phases and elements. Materials can be solid, liquid, or gas, depending on their state. And when it comes to their physical and chemical properties, they're categorized as metal, metalloid, or non-metal. Metals are shiny and conductive. Metalloids have properties of both metals and non-metals, while non-metals are typically dull and poor conductors. So next time you pick up a material, think about its phase and properties to understand it better. Knowledge is power, my friends.
As you see, the periodic table categorizes the element into three main groups: metal, non-metals, and metalloids. Metals, as you know, exhibit characteristics such as shyness, malleability, ductility, and excellent conductivity of heat and electricity. In contrast, non-metals are generally dull, the brittle and poor conductors of heat and electricity. Metalloids possess the properties that fall between those metals and non-metals. The arrangement of elements on the periodic table offers insight into their classification. Elements positioned on the left side are typically metals, while those separate the metals from non-metals are classified as metalloids. On the other case, the materials can be classified based on their geological origins or biological functions. Let's back to the classification on the phase. We said in previous slide, materials can be classified based on the phase into solid, liquid, and gases.
Hello,
Now,
brothers and
let us see the sub-classification of the solid. In the field of material science, solids are classified into three classical sub-classifications. Those are metals, ceramics, and polymers. Composites, which are composed of two or more distinct materials, are a special additional classical sub-classification. Students, now let us see the next topic, which is very basic for this course, the foundation of material science, exploring atomic structure, bonding, and crystal structure. Students, before we proceed in detail into this topic, let us practice these activities. Please sit in pairs and write down the answer of this question. Here are the answers for your question. Let us discuss about atomic structure and bonding.
Atomic structure. In this video, we're going to go over atomic structure in a very simplistic and basic way. Atoms are the basic unit of chemical elements. They contain subatomic particles in their nucleus and in the electron cloud that surrounds the nucleus. These subatomic particles include protons and neutrons, which are located in the nucleus, and electrons, which are located in the cloud or field that surrounds the nucleus. Protons have a positive electrical charge, neutrons are uncharged, and electrons have a negative charge. The number of protons and electrons are equal, so atoms are electrically neutral particles. If we look at a model of the element carbon, which has 6 protons, 6 electrons, and in most cases 6 neutrons, we can see the electrons in simple rings or shells surrounding the nucleus. Each shell represents a different energy level, and it can only hold a certain maximum number of electrons. In chemical reactions between atoms, only the electrons in the outermost shell participate in the resulting chemical bond. In atoms with only one energy level or shell, 2 electrons are required for stability. If we look at helium, which has only one shell or energy level, we see that it is full because it contains 2 electrons. So helium is stable, and there is no naturally occurring compound containing helium. Hydrogen, which also has only one ring or shell, possesses only 1 electron in its shell, so it's chemically reactive. In atoms with more than one energy level or shell, 8 electrons are required in its outermost shell for stability. So neon, which has 8 electrons in its outermost shell, is stable, and oxygen, which has only 6 electrons in its outermost shell, is chemically reactive. Atoms that do have fewer than 8 electrons in their outermost shells will try to share, gain, or lose electrons in order to become stable. This is called the octet rule, but there are some exceptions, such as we saw with hydrogen and helium, which have only one energy level or shell. And that be the basics on atomic structure.
The smallest unit of the matter is an atom, which is the basic unit of the chemical element. Atoms are composed of 3 subatomic particles. As you remember from your lower grade chemistry course, it contains positively charged proton and neutron, which is neutral, in the nucleus, and negatively charged electron orbiting the nucleus. The number of electrons determine the atomic number and the element of the atom, and this arrangement is referred to as atomic structure. Atoms become ion when they gain or lose electron. Losing an electron results in electropositivity atom, creating the positive ion as there is an excess of positively charged proton. Gaining an electron leads to electronegativity atoms forming negative ion as there is no spare proton to balance the added electron. Additionally, when atoms chemically combine, whether of the same or different types, they form units known as molecules. Now, let us come back to about bonding. Before that, why study atomic structure and intra-atomic bonding?
Have you ever pondered the question of why diamond, an object of immense beauty and strength, is the hardest known material, while graphite, used in your everyday pencil, is relatively soft? Both are made entirely of carbon, so what makes them so different? Well, the answer lies in something known as interatomic bonding. Atoms, the building blocks of matter, are always eager to bond with other atoms to reach a state of stability. This tendency to bond and the manner in which they do so determines the properties of the material they form. This, in essence, is the concept of interatomic bonding.
Thus, we have the following types of bonding.
The chemical bonds are broadly classified as ionic bond, and covalent bond. Let us discuss these chemical bonds in detail in this module. The bonding which results due to the complete transfer of valence electrons between atoms is called ionic bonding. It is a type of chemical bond that generates two oppositely charged ions. Ionic bonding is observed because metals have few electrons in its outermost orbital. By losing those electrons, these metals can achieve noble gas configuration and satisfy the octet rule. Similarly, nonmetals that have close to 8 electrons in its valence shell tend to readily accept electrons to achieve its noble gas configuration. In ionic bonding, more than one electron can be donated or received to satisfy the octet rule. Sodium metal has electronic configuration as 2, 8 and 1. It has one electron more than a stable noble gas structure. If it gives away that electron, it would become more stable. On the other side, chlorine has electronic configuration as 2, 8 and 7. It has one electron short of a stable noble gas structure. If it could gain an electron, it too would become more stable. Thus, the sodium atom donates its valence electron to achieve stable octet configuration. This creates a positively charged cation due to the loss of electron. The chlorine atom receives one electron to achieve its stable octet configuration. This creates a negatively charged anion due to the addition of one electron. The sodium ions and chloride ions are held together by their strong electronic attractions between the positive and negative charges. Covalent bonding. A covalent chemical bond results from the sharing of electrons between two atoms with similar electronegativities. The electronic configuration of chlorine atom is one electron short of the argon configuration. The formation of the chlorine molecule can be understood in terms of the sharing of a pair of electrons between the two chlorine atoms, each chlorine atom contributing one electron to the shared pair. In the process, both chlorine atoms attain the outer shell octet of the nearest noble gas, that is argon. The dots represent electrons. Such structures are referred to as Lewis dot structures. Thus, the chlorine atoms are joined by a single covalent bond. A single covalent bond is formed when one pair of electrons are shared between two atoms. It is depicted by a single line between the two atoms. A double bond is formed when two atoms share two pairs of electrons with each other. It is depicted by two horizontal lines between two atoms in a molecule. This type of bond is much stronger than a single bond, but less stable. This is due to its greater amount of reactivity compared to a single bond. For example, in the carbon dioxide molecule, we have two double bonds between the carbon and oxygen atoms. When three pairs of electrons are shared between two atoms in a molecule, a triple bond is formed. It is the least stable out of the three general types of covalent bonds. The two carbon atoms in the ethyne molecule are joined by a triple bond.
Another type of bonding is the metallic bond, which is metal to metal bond. It is the atomic bond. It is the atomic bonding mechanism in pure metals and metal alloys. The metal bonding involves the sharing of the outer shell's electrons by all atoms to form a general electron cloud that permeates the entire block as shown in this. Cloud provides the attractive force to hold the atom together and form a strong rigid structure in the most cases. Because of this general sharing of electrons and the freedom to move within the metal bonding provides typically property of materials characterized as such good electrical conductivity, good conductions of the heat, and good ductility. Another bonding type is van der Waals force. They are very small force of the attraction acting between atoms in the case where the formation of ionic or covalent bond is not possible. Basically, similar forces also act between atoms which are already bounded in the neighboring molecules, giving rise to the weak van der Waals force between long chain molecules in the polymer. This is all about today's lecture. Please don't forget to subscribe, like, and share African Farming Tech YouTube channel. We will make difference together. Thank you for your attention.